Now, when I calculate torque, the very first thing is that I want to determine the center. So the center of this triangle is going to be right there. So the center of this triangle is going to be right at this point. So this is called the center of mass. So the center of mass is such that the distance from this point to this point is B over 2. And the distance from this point to this point is also B over 2. Now, when we calculate torque, torque is the cross product of the position vector times force. So you take the position vector and then you just cross it with the force. So it means that I can calculate the torque. I don't need to worry about F1 because F1 is 0. I don't need to worry about F3 because F3 is also 0. So when I calculate the torque, I only take the contributions that come from F2 and F4. Right? So the way we're going to do this is that we're going to say that, so for F2, so let's say that F2, so F2 is equals to IA, B, A hat, and then my R2, so my position vector at that point is negative B over 2, I hat. And then my F4 is equals to IAB K hat, and my R4 is equals to B over 2 I hat. So R2 is a position vector from the force to the center of mass, right? You guys see that? So now, let's calculate the torque.
So from the force to the center of mass?
Yes, so from this point, so we said that if this is the point of action of the force, right? What is the position vector from this point to this point right here?
So then wouldn't F2 be positive B over 2I if it's going from the left to the right?
So you can just think about this center of mass here as the point 0.
Yeah.
So because F2 is to the left.
So you go from the center of mass to the.
Right, yeah.
Oh, okay, you said it back.
Yeah, so F2 is to the left. So it means that F2 is negative B over 2 I hat. And then F4 is to the right of the center of mass, and so that is positive B over 2.
Okay.
For the force on 4, would it be negative?
F4,
Yes. Yeah.
yes, it's negative. That's correct. So F4 is negative. Now let's calculate T2. So torque number 2, which is R2. Now, if you do R2 cross F2, because I cross K, so I cross K is negative J. So the negative is going to cancel with the negative. So this will give you I A B minus B divided by 2. I'm sorry, J hat. And let's calculate torque number 4. So this is R4 plus F4. So R4 is I, F4 is negative K. So I cross negative K again gives me J. So you can see that this will also be equal to I. And so finally, if you sum all of that, so just this is wrap up everything here. The total torque, which is T2, torque number 2, plus the contribution from, so if you add all of that together, it gives you IAB, and then, so let me see, running out of space here, I. J hat, I'm sorry, it's J hat. And so this is the magnitude of the torque, and the J hat gives me the axis of rotation. So the J hat gives me the axis. So what I've just showed you is that the sum of forces is 0, but the sum of the torque is not 0.